Hey guys, it's Dylan here, and today we're going to be taking a look at the first CS project for CS135. Not too much of a hard project, so I'm sure a lot of you guys will be able to do it without much help. But when learning C syntax, sometimes it's nice to just have a point of reference, to check your work. So I'm going to be going through how to make this project. This is technically from last semester, as you can see. But I am assuming that it's not going to be that different semester to semester, and if I find out it is, I will definitely remake this video. So let's jump right in. I'm going to pull up my terminal. You have a bash shell too, if you've correctly installed VMware. I'm just going to be doing it in my VS Code 1 in Windows though. So first thing I'm going to do is I'm going to touch circle.c because that's the name of the project. And you could do this however you want. You could go through the file system and just make that file by yourself. However you want to do it. It's not that important. Now I'm going to open this up. So we have a blank C file. Header files are super important when it comes to, well, your grade in this class. They're not really ever important to much else. So we're going to give it a name. And we'd say circle.c. Pardon me. And then we would say author, and give it all this information. Okay, so perfect. I'm gonna let you guys go through and fill that in for yourself. All right, super important for your grade in this class, okay? It's just kind of like free points that you don't wanna miss out on. And so I don't wanna emphasize that, not enough. So we're gonna hashtag include standard input output, pardon me. There you go, .h. And that's going to give us access to the printf, scanf functions, okay? So basically we're importing that library so that we have access to all those functions. And so what does the problem ask us to do, right? So it says write a program that will ask the user for the radius of a circle, right, shown by the diagram, that has been inscribed in a square. Then your program will calculate and print out the diameter of the circle, the circumference of the circle, basically all this stuff about the circle and the square, right? Given the radius. So here's how, these are really key when we're like looking at how to do these problems, okay? So usually this is what we want to see being output by our program. And the underlined stuff is the inputs, okay? Those are usually big hints about what your program should be doing. Now, before we can actually start programming into this though, we have to have a main function, okay? It's always an integer function, and it's integer main. I like to put void here, but you don't have to put anything. And that's all you gotta put essentially. And then return 0, I like to do right when I start so I don't forget it. Now, our program's gonna start right away by printing out some stuff to the user. So we're gonna use printf, okay? And that's gonna allow us to print straight to the terminal. Don't forget semicolons after everything you put. And right now we can just print what's called string literal. So we can say, I'm not gonna bother typing it out when it's already done right here. Feel free to copy and paste a lot on these projects. It's gonna save you a lot of time if you're a slow typer like me. And now, if we were to print this and just give this a run right now, okay, so we can do that. We can say gcc, the name of the file, which is circle.c/o or -o, and now we give it the name, except I'm not going to give mine the name, I'll just take the a.out that it gives me, okay? So it's going to compile, took a second there, and now I have to say, because I'm in Windows, a.exe, you'd have to say /a.out. Don't worry about that. Now it says this program computes values related to a circle. My editor already automatically gives a new line in the terminal. Yours is not going to do that. So what we really want to do is put a \n, and now let's run it again and see what happens. Basically, that's going to be the new line character. It's basically like hitting enter on your keyboard, and it's pretty important. So otherwise, if you didn't do that on your terminal, you should see that this something wrong right here is connected to that, and you want it to be on a whole new line. Now, what is the next thing this asks us to do? So we have to take an input for the radius, okay? So once again, we can just copy and paste this. We can print f, don't forget that semicolon, and the quotes. Now this time, we don't want a new line, because the new line is going to basically have it skip the user inputting anything. So we want it to wait right here for the input, okay? Now we want to catch that input once they hit new line, so we're going to use the scanf function. The scanf function, we have to tell it what it's being given, okay? So I want to say that in this case, the radius will be an integer. Given that it doesn't show it not being an integer, I'm just going to assume it's an integer. So we're going to say int radius. Okay, perfect. And we don't have to give it a value to start with. We can just initialize it and just tell them, hey, we're going to give you a value later. When we take in an int from the scanf function, we have to tell it %d. So look for an integer, and then where to store it. So we give it ampersand. So we're giving it basically like the name of the variable, but where it is too. That's what the ampersand is, and you'll learn about that later. So radius. Okay, perfect. Now what that did was it stored it in our radius. So just to prove that, we can print f and print out our radius, okay? Just to show proof of concept here. And this is a good thing to do throughout your code as you're writing these programs. Just make sure you've gotten it right so far. Oh, see, I almost forgot my semicolon. But just keep printing stuff out and saying like, okay, is it getting this value correctly? Is it storing it correctly? All that. So we're gonna have it print out the variable and a new line. And let's even say radius equals, right? That way we know what it's printing. And then give it just radius. Perfect. Now if we give this a compile, no errors. Perfect. Enter a value for the radius. I think it said 7 for that. Perfect. And it prints out the radius is 7. This means we've collected it right here in the scanf. We've stored it into the value radius, this variable right here, this integer. Then we just printed it out again for concept, okay? So what I'm going to do is I'm going to comment that out because I don't think we're going to need that anymore, but we might want to print some stuff out later, and I'll want to leave it there for that. Okay. Diameter. So if we want to print out diameter, we know that diameter is 2 times the radius. So I'm going to make a new kind of block of code right here. Oop. We're going to say print f. And essentially now it's just going to do a bunch of calculations for us. We put the %d right here, right? Because the %d is an integer. That's just essentially saying, hey, we're taking just a normal integer. And in this case, we're putting one in. So whether you're using scanf or printf, you're just saying this is an integer. And those functions know how to handle that. So then we're going to want to give it the radius, like we did when we were printing it out for proof of concept, right? Except we don't just want to give it the radius, we want to give it 2 times the radius, okay? And we can do that just right there, no problem. We don't have to, if you wanted to, you could make a whole nother variable called diameter, right? And there's nothing wrong with that, and you could just, do the math. If you want to, feel free. I just won't be. Okay. I'm not going to show a proof of concept for that. We'll just kind of debug it all at the end here. So what does the next thing ask us to print out? It says it wants the circumference of the circle, okay? So just a quick reminder on the formula for that, that would be 2 pi r. Put it right there, sorry about that. Okay, once again, we're gonna wanna tell it, hey, we're giving you a integer value right there. And we're gonna have to put something in here, okay? This is gonna be where we put the circumference. One thing I think he's gonna want you to do is we're gonna define what's called a macro, okay? So if we use hashtag define, and then we're gonna wanna say pi 3.14, okay? I think that's how you do that. So what that does is it says that this thing pi is now going to equal 3.414, which I think is all the exactness you need, the precision here. So I'm going to check that right now. So if we do 2 times radius times pi, okay, our macro. Now what this is doing is it is multiplying 2 times the radius times pi and putting that right here into this %d, okay? And I think we're going to get a problem with that. And the reason for that, well, let's just run it and show. All right, so we're going to give it 7 because that's what it wants. Oh, forgot my new line character somewhere. Right there, that is. Let's give it a new line. And you see what I mean, where it kind of merges the two strings together if you forget your new line. So let's add our new lines. And let's just rerun that so we can truly like see the problems here. Recompile it. Oh, I'm sorry about that. There we go. We're going to give it 7. Okay. The circumference of the circle, that is obviously not right. So I think the reason for this is because right here I said %d, and this was what I was going to point out. But technically this thing, pi, is irrational. It's going to have some decimal value, okay? So meaning it's a floating point. So it's not going to be able to basically fit in here. It's not going to be able to go in there. It's going to cause some problems. So try %f, and that's going to be for a floating point. We're going to recompile it. Give it 7. Perfect. Now it did exactly what it was supposed to. So if we look, 43.96, and our output 43.96, and a bunch of zeros. I don't think he's going to care about how many. Actually, it probably does specify how many decimals he wants it out to. Yeah, he wants that. And that's where he says this is a good place for define, right? And he only wants 3 digits after the decimal place. There's a very specific way to do that. Now, what we do is we say point. You could also say 0 point, but 0.3. So anything after this point is your precision, okay? That's going to be essentially how many decimal places it knows it needs. Anything before the point, if we were to put some number there, would be how many spaces to allot that number when it prints it out. If you gave it like 10, it would, there would be 10 spaces reserved in here for it to be printed out. If you leave it blank, it just uses as many as it needs. So I recommend you do that unless told otherwise. Now, let's recompile it, run it. We're going to give it 7. Okay, we have 3 decimal places. Perfect. Now, on to the next thing it wants us to print. So we're going to use our printf function once again. Okay, and I just do that because I'm assuming we're going to need to give it a value. So it wants the area of the circle. Okay, so let's just give that a copy. And because we know what this value is going to be, we're going to give it %d and a new line character. I'm not going to forget that this time. Now, what we're going to want to put in here, so the formula for area is going to be pi r squared, okay? There is a function for squared, but it requires us to import like a whole nother math library. And for something so simple, I don't think we necessarily need to do that. It's just not important at this stage in computer science 135. So let's just do radius times radius, because that's going to get us the same thing as just squaring it, right? Times pi, our macro, okay? Perfect. Don't need that comment there. I was going to type some stuff, but it wouldn't really format any better than that would. All right, so we can give that a check in a second. Once again, I'm just going to kind of keep progressing. We're going to give this thing some stuff. Perfect. Let's go see what the next thing it wants is. The perimeter of the square, okay? Now keep in mind, the side length of the square, right, is going to be 2 times the diameter. And the area for the square is just the side length squared. So, after we put in the %d, what we want to give that %d is the 2 times the radius times 2, which we can simplify to 4, but for sake I'll leave it out, radius. Again, if you wanted to use a diameter variable and just store that earlier, then it would save you some redundant code right here and here. I'm not too worried about it right now because it's not going to change the way our programs run. And then here, why don't we just give it a quick check so we've gotten a few more things down. We can compile it, run it, give it 7, right? Now, oh, see, so this is going to be a floating point again, and I forgot, and that's why we're getting this weird error of it printing out some weird stuff we don't understand. Okay, and I think what it's doing is that it's basically printing out this float without the decimal. And I think that's why we're getting such a big number, and that's why it doesn't quite make sense. Sorry about that. So, if we check our outputs, 56, 135, that, 56, I didn't rerun it, but this did remind me that we're also only going to want that precision right here, right? Okay, let's rerun this. Give it 7. Beautiful. So we could do a quick side by side. It doesn't want to drag that. That's fine though. So we can still keep up our terminal and just see that our output's matching up perfectly so far. Actually, oh, I forgot parameter of the square. Okay, that's my bad. So I skipped right over that. I used the area function. Okay, sorry about that. All kinds of confusion here. Let's just take this right here. So we're going to fix our code. See, this is what programming is all about. You know, you make a lot of mistakes and you just get there in the end. Colon. Okay, so we're going to need the area of the square, and we're going to want to print that out. Print f. I do highly recommend, guys, though, that you do compare exactly, like you just copy and paste, because if you don't want to get docked down points off of an assignment just for having a silly typo. It's not, it feels good. And just this shows again why comparing your output, your terminal output, to what it says it should run like is super important, because that's one of the easiest ways to catch errors in this class. So I had totally forgotten to make a function that prints the parameter. I had the words in there, but I just kind of was, messed it up. So the parameter we know is just going to be 4 times the side length. So we can just say 4 times, because it's 4 sides to a square. Side length, we know side length is just 2 times the radius. Yes, you could technically reduce all this, but why do it if you don't have to? Let the computer do that. Okay, let's give this one more run as a proof of concept here. Okay, give it 7. Beautiful. We should be able to just check them now. So you can see that all of our outputs are falling exactly in place. And we're on to the last one already for part 1 of the problem. So we're just going to copy this thing. And this is asking for the difference between the two areas, okay? So we're going to say print f. So use our print function. This whole thing right here. Then we know this is going to be a float, or we can at least assume it's going to be 0.3, because we want 3 places. And then new line character, don't forget that just because it's a float. Now what we're going to give that, right? So if it's the difference between the two areas, we've already calculated the area of the square and the area of the circle. And we know that the circle's area is always going to be smaller. Cancel, sorry about that. So if we just take the equation for the square's area, then subtract order of operations, this is all multiplication, you don't need parentheses really, the area of the circle, right? Sometimes people like to kind of give that space in there. So that's essentially what we're going to do, okay? We're going to print it out just like this. And now, if we give that a run, we should see that we've completed the first problem. 7. 42.140. 42.140. Perfect. So that is circle.c done, okay? So we can now close that, save it, submit it, do whatever you need. Now, what I'm going to do is I'm going to touch our next file. Touch is just essentially the command you can use to make a file of a given name. And then you guys might use gedit or pull it up in the text editor, however you want. Date.c is what it's going to be called. Date.c. Perfect. So we have a date.c. I'm just going to open it up in my text editor. Now, once you've typed this out, just copy and paste it between all your projects. You are just always going to need it, always going to want it. Bam. Now, we're probably also going to have, because it's, trying to get us, quote, familiar with the standard input output, the scanf printf, we're probably just going to want to put that in there too. We're always going to have our int main function, okay? You're always going to have that because that's what the GCC compiler knows to run first. Again, we're not taking command line arguments. It's never going to have arguments until way later in the semester. So I like to put void in there just to show I know. It's not something you have to do though in any way. Okay, and then return 0 at the end. Perfect. Now, what we're going to do is we're going to see what this exactly wants us to do. So we're going to take a bunch of dates in this form, okay? Okay, nice. So that won't be too hard. Basically, okay, so it's only ever going to take 4 dates. Perfect. So we have a given amount we know it's going to take. So do I just copy this? I don't know exactly what variables we're going to have yet, but I'm just going to go along with printing them out, and then we can figure out how exactly we want to collect them, okay? So enter date 1. And now we're going to want to not put a new line because we want to actually wait for their input right here, right? So we're going to do scanf, which is going to pick up the input. That's what goes and scans what they typed in. So we're going to be looking. Now this scanf is going to be a lot more complicated, right? So the days is going to be an integer, the months is going to be its own integer, and the years is going to be its own integer, okay? And essentially I'm just going to define a lot of variables because I don't know if you guys will have known arrays yet or not. Essentially you could do the same thing with an array though. So int, we're going to say day 1, day 2, day 3. Definitely don't put the space there. Day 4, okay? We don't need to give any of them values because we're just going to give them as they go along. Now, essentially, I can copy this and say month and then say year, right? Perfect. Then what I can do is all right, these are just kind of some crazy Visual Studio Code tricks I know from keyboard shortcuts and whatnot, so don't be stressed if you don't know how to do that. It can be intimidating to see that at first. So here's just some, some variables that are going to store all these components. Now we know that we're going to have we're going to have an integer followed by a forward slash, followed by an integer, followed by a forward slash, followed by an integer, okay? Now, this thing is we're going to want to take all 3 of these integers we pick up and give them to these different variables here, okay? So we're going to say day 1, we're going to say month 1, wait, sorry. Okay, yeah, so it does want days first, good. So we're going to say day 1, month 1, and year 1, okay? And we're going to store them all in those variables. Oh, except I almost forgot. The scanf function needs an ampersand. Do not forget it. It's like stomping on your left foot. Just don't forget it. So now we know we have to do this 3 more times for all the different dates. I'm just going to put them in one big block. Feel free to format that to your heart's content. And now I'm just going to take this 1, that a 2. Actually, I'm going to use my crazy tricks again. Just keep in mind though, you have to turn all these into 2s. You have to turn all of these into 3s and all of these into 4s, okay? Sorry that that's a lot of changing, but I find this is the quickest way to do it, just by typing them out and then copying and pasting. Great, so what you'll notice is we have the dates being stored in each of their corresponding variables, okay? Now, what does it want us to do? It wants us to then print out like an extra space, right? So printing out an extra space is easy. We can just, oops, sorry, wrong file. I'm just gonna close that. We can just print out a new line character with like nothing else. So just print a new line, bam. We can just keep on with our business now. That's gonna give us that extra little space that you saw. And now, here's where we print out all of our dates again. Okay, so yeah, so it wants this kind of tabular method where we just put them into a table. This is a pain in the butt, not gonna lie. This might end up being kind of a long video, but that's okay. I'm gonna try to get it done as fast as possible. So it looks like they should be separated by tabs. The year column should occupy 4 spaces, yeah, because you're not going to get a year longer than that. Or value should be right justified. Okay. Sweet. So we're not going to tackle too much at once here. Let's just start by printing out some of the stuff we want. Okay. So we're going to print out our headings. So year. I want to say those were lowercase. We're going to use this \tab thing. And so \T is in the same way your new line characters like the enter key press. This is like the tab key press. Then we're going to say month, I want to say. And then day. And I'm going to go check that because I have no clue. Don't forget a new line at the end. Yep, so that is how we're doing it. I'm just going to start by now printing out the stuff, and then we'll worry about how to format it exactly later, okay? So printf. We know we're going to want, so we're going to have all of our, right, for each date, we're going to have our day, month, and year all being filled in right here. So I can essentially copy this, but get rid of the ampersands. And then don't forget to delete your ampersands because the print function does not want ampersands. You'll kind of learn why later, but it's not super important. So this would be great, except remember we want tabs between the numbers too, okay? So we're gonna want tab right there, tab right there. Oh. Perfect, okay. And then a new line right here. So this is our format. We can copy this down now. And that's for our 4 dates, okay? So here, what we want to do, oh, I forgot my semicolons. That's why it's giving me some red lines. Perfect. Now we're gonna have to do this thing again. So I might just cut this out, but actually, that was surprisingly quick. I forget about how great these shortcuts are sometimes. Visual Studio's Code Guide, guys, hashtag not sponsored, but I do love their editor. Now, the last thing to do is to give it the right width, okay? So this is gonna print out our, day, month, year. Oh, except you notice we have it backwards, okay? So I just copied and pasted without really thinking about the form, okay? Day, perfect. Now I'm just going to have this, I think we can expedite this a little more. Perfect, and then I can copy day and put this down here. So sorry about that, guys. All right, yep, sorry about that, guys. So we've cleaned up all that. Now, what we need to do is going to print out the years column, the months column, and the days column. They'll all be the same width apart, and that's all great. But it was talking about like right justified, okay, and how many spaces to occupy. So let's worry about the number of spaces to occupy first. 2, 2, and 4, right? That just makes sense. You're not going to get things longer than that. So what we want to do is, this is our years, right? And so for the years, we want to just put a 4, okay? No decimal point, nothing. It's just a 4. That's how many spaces it's going to allot, like I was kind of mentioning earlier. Days, it's going to be 2, or sorry, months going to be 2, days going to be 2. Bam. Because we're only going to deal with 2-digit numbers there. So we have our spacing there right, okay? Now, I'm going to run this and double check because I think, let's just run it here. Do that first. But except I'm not compiling circle. I want to compile date.c. So let's just see what we have so far. I'm going to fast forward through entering all these dates. So you'll see that we are actually really close to being done. So this is already right justified like it's supposed to. Oh, of course, yeah. So the only thing we did not get right was the days. So these kind of automatically justified because it automatically justifies to the right with respect to your spaces. So you'll notice that our days column, I can't highlight just that, but our days column's off, okay? So it wants them to be in line with the D. So to do that, I want to say we put a negative here. Perfect, so we have a -2. And let's just do that again. And bam, you can see that the negative was all we needed. It left justified those. And now you're done with this project too. Save it, submit it, clean it up. You are good. One last recap, friendly reminder, make sure you have these header files. They're worth free points. And essentially, that is all there is to this project. So thank you guys for tuning in. I'm going to be, okay, there's a challenge. We can go over this too real quick. If I remember right, this is super easy. So modify your previous program. So we would essentially make a new file. I'm just going to copy, right, paste, bam. And then you'll want to rename that. So we rename this one to date_c.c. Sorry, I don't have some cool keyboard shortcuts to flex with that one, but now, okay, so this is wants us to make it so that if they have just one digit, right, if they're one digit days or months, that they still have a 0 displayed, okay? So here's what they mean. The best way to see is just look at it, right? So 05, 03, 02, 00, right? So that's where I was saying don't worry about those decimal points. Well, now actually you kind of got to. So what that's going to do is we're going to want to give it, if I'm right, a 0.4, a 0.2, and a 0.2. Or that's still 4. Don't know what I'm saying. 0.2. So that's going to be our precision, right? So if we don't have that many filled in, we still want to replace it with zeros, and the D's just kind of know to do that. So I'm going to take these, I'm going to copy them down. Okay, I'm going to take these, and because there's a lot of them, I'm going to go get all the next instances of these. Oh, I don't want to scoop those up too. Okay, just copy and paste it the old-fashioned way. No fancy keyboard shortcuts for this one. I'll probably fast forward through a lot of those. Perfect. Now that we're done with that, let's just give it a run. Except don't forget, now we're compiling date_c.c. Now that we've compiled that, we can give it the old run. And back to our favorite part of this entire project. All right, and as you can see, it functioned exactly like I was hoping it would anyway. So that was what it was, is this leading 0 thing, and make sure you're always editing the right files with these challenges. It's something very easy to get mixed up here. All right, guys, so that is your entire project and 10 free extra credit points going on. Thank you guys for watching. Hopefully this wasn't a complete mess, and just, stay subscribed, hit that notification bell so that you can continue to see these as they come out and stay just ahead with your projects. I know life catches up sometimes and you just do not have time to get these done. I will have a link to a Google Drive with my folder down in the bottom. Just remember, if you do directly copy and paste it and they think you're cheating because a bunch of people copy and paste it, I'm not responsible for that. So try to modify it a little bit. Make sure your header comment, doesn't say something like this, right? And that'll be it. Thank you guys.